Hello everyone, welcome back to the YouTube channel Devotion of Knowledge. Today we are back again with another YouTube video, and in this video we are going to answer a question that almost all of the computer engineers are not aware about, because everyone knows that computer stores everything at binary level in the form of 0 and 1, but very few of us are aware that how actually those 0 and 1, which are binary bits, stored at hardware level in actual form. How it is 0 and 1, whether it is any kind of symbol, any kind of data, how this memory is actually handled at hardware level. So stay tuned till the last of the video, and we'll try to answer all these questions, that how SRAM, DRAM, SSD, HDDs, etc. store 0 and 1 at the most basic level. So stay tuned till the last of the video, and let's begin. Okay, so first thing that we should know that is 0 and 1 is not any kind of symbol. So basically what we think that at the hardware level 0 and 1 is stored, so basically it might be a symbol that denotes, okay, this is 1, this is 0, but no, that's not the case. It is basically a physical state of many aspects as per the use case. For example, whether the voltage is high or low, this is one of the case. Another is capacitor is charged or empty. Another is electron trapped or free. Is magnetic region of that particular part is facing north or south pole. So if a capacitor is charged, it may denote that it is 1, and if capacitor is not charged, it is empty, then it might be 0. So all these are various kind of physical states that are used to store 0 and 1 at a binary level. So right now we knew that 0 and 1 was not a symbol, it's basically a physical state. Now all these things are use cases. Capacitor is the case of DRAM, electron trapped is a case of SSD. We all will understand that how all these things are working at root level. So okay, let's move to the next part. The transistor is the most basic part of this memory handling, or it is the lowest part of the architecture. So basically transistor acts as a switch which is on and off. Now those who came from science background, they all would be knowing its basic architecture, but okay, if you are not, then let's go. Source is an input of electrons to the transistor, drain is the output, and this gate is a controller. Okay, this might not be making any sense to you right now, but let's understand. So when an electric field is applied to the gate, it basically creates an electric field between a silicon, which is a semiconductor, and it allows electrons to the line between source and drain. So if an current is applied to gate, then it will allow, or it will create an electric field. This is source, this is drain. It will create an electric field so that electrons can flow between this source and drain. So whenever the current is, a voltage is applied to this gate, current will flow, and this will denote as 1. And when the gate is switched off or no voltage is applied to gate, this particular path will be inactive and it will be denoting 0. And believe me, transistor is very small. It is basically in a range of 3 to 5 nanometer. And for an analogy to give, human DNA is of 2.5 nanometer in length. So believe how small is this thing, transistor, and this is the most important invention of the electronics, or I would say computer science and electronics industry, because this is the main base or a root of any hardware industry that we will be understanding right now. So on any circuit, transistor is the most eternal or the most basic part which is working behind. Okay, so now let us understand that how transistor is used to create a static RAM. Now see, RAM is always of two type: static RAM and dynamic RAM, which is also known as DRAM. So static RAM is used to create CPU's L1 cache, L2 cache, means those who are not aware, this is the memory which is connected to the most basic part of the CPU, and it is used for very fast computations because it is very fast and it is very efficient. So let us understand that what is this feedback loop. Now the problem is that transistor can allow a current to pass and form 0 and 1, but it can't remember any memory or any value. So how to handle this? For this we create a feedback loop. What we do, we connect two inverters. This is inverter 1, this is inverter, okay, let me write in a more beautiful way. This is inverter 1, this is inverter 2. So what inverter does is, whatever input you give, it will output. If you input it 0, it will give 1, and when this 1 is goes into inverter 2, it will output 0. So it is connected like this. So whenever I am giving 1 as an input, it will give 0, this 0 to this inverter, and 1. So overall, whatever input will be given, it will be flowing continuously in this loop. So it will basically create a stable loop so that it can remember the memory that, and it will be flowing for infinite time unless and until current is not switched off. So basically it creates a latch, as it is mentioned over here. Latch is basically a system and it uses 6 transistors create this stable loop, to store 1 bit of information. To store 1 bit of information, it uses 6 transistors, and as a reason it is very fast in computations, it requires 6 transistors. So this is basically quite expensive, and we can't store billions of bits in this because it is very expensive, and it is relatively very large because it uses 6 transistors. So static RAM is used for in your L1 and L2 cache and uses 6 transistors to create the stable loop to store 1 bit of information. Now in the case of dynamic RAM, which is also known as DRAM, when we see in the laptop that my laptop has 16 GB of RAM, 32 GB of RAM, we are basically talking about a dynamic RAM. So in case of dynamic RAM, transistor acts as a gatekeeper and the actual charge is stored in capacitor. Now those who are, as I say again, from science background, they would be knowing capacitor can store charge. So when transistor is allowed to flow charge or current, capacitor will store the charge, and when capacitor is charged, it will denote 1, and if it is not charged, it will denote 0. But the problem is that it is a very small capacitor, so in a time around 60 to 65 milliseconds, capacitor gets discharged. So for this reason, for not making it discharged, all those capacitors are charged or refreshed thousands of times. to retain memory. So it constantly uses electrical power, and this is the reason when we switch off the laptop, RAM's memory is erased, or we can say lost. That's why we say RAM is a volatile memory, because we require constant electrical charge to recharge it or refresh it. So a processor or is going on the back end, and it is constantly testing that if capacitor is charged, then it will apply voltage to the transistor so that capacitor can be charged again. If it is not, then it won't apply the voltage, and this process is undergone thousands of times in a second to retain the memory into the RAM. And it basically constitutes of just one transistor and one capacitor, so it can be used to design a relatively larger memory as compared to DRAM. So memory of DRAM is generally more or greater than SRAM, because over here there were 6 transistors, and over here it is just one transistor plus one capacitor. So that's why DRAM can store larger amount of memory as compared to SRAM, as well it is more cheaper. So that's why DRAM has 32 GB of RAM, while SRAM is quite less in memory as compared to DRAM. Now, the SSD is something which stores memory for, we can say, infinite time. Let us assume, because whenever a laptop is switched off or anything like that, it contains memory into SSD, and this is the most interesting use case of transistor. It basically uses a floating gate transistor. So basically what happens is, there is one conducting material which is placed into center, and around it there is one insulating medium, and whenever current is applied through this insulating medium, now you will say that as it is an insulating medium, current or electron can't penetrate through this medium. But here comes the concept of quantum tunneling. Now, those who are aware about quantum mechanics, it basically explains that electron exists in the form of particle as well as wave. So if electron acts as a wave, it is basically having a probability of existing into any surrounding, existing into space. So whenever a very high voltage means around of 15 to 20 volt in the range is applied through this medium, electron tunnels through this insulating medium, and it is trapped inside this conducting medium. This phenomena is termed as quantum tunneling. So electron penetrates through this insulating medium, and it is trapped inside this. Now once electron is entered with this high voltage inside this conducting medium, as it is surrounded by this insulating medium, it is relatively stable inside that. So we can say that electron is trapped inside that conducting medium. So once it gets into that, it cannot penetrate or it cannot come out of it. So we can say that it is stored, or we can say trapped, for infinite time. And now a question might arise that how to remove it. So in that case, to remove it, we have to apply reverse current or reverse voltage, I would say, and this electron will come out of this particular conducting medium, and this memory will be freed again. So if voltage is trapped inside, it is termed as 1, and if it is electron is trapped inside, it will be termed as 1, otherwise 0. Now while trying to find that whether it is electron is trapped inside or not, as as this is insulating medium and inside this conducting medium. So if electron is trapped, the overall electric field around is increased. Overall electric field around it is increased. So while reading the memory, it is checked that if there is some or certain electric field around, above a threshold which is decided, it means electron is trapped, and hence it is 1. Otherwise it is 0 if no electric field is there. So this is mainly possible because of quantum tunneling, and for this floating gate transistor, which is a special type of transistor used, which has conducting medium into middle and it is surrounded by the insulating medium around. So this is the most interesting part. And yeah, many of you might get a question in their mind that what if electron is given some energy, won't it get excited and get removed from that conducting medium? This was the question that came into my mind, and when I searched about it, answer is yes. See, energy required is quite high in amount, but for example, if heat is there, if so much heat is provided or is surrounded, the electron might escape. Electron might escape from conducting medium. So we can say memory can get leak. Memory gets leak, and this is the case in high heating laptops or devices. SSDs gets corrupted. This is the reason that when a laptop or device is very much heating, SSDs can get corrupted because memory gets leak, because electrons escape in high energetic environment. So this is the reason that SSD gets unfunctional or corrupted in case of high heating laptops or in summer seasons. So yeah, I think this was the video. I am sure that all of you might have find this video very interesting, and all of you have now got the idea that how this particular thing 1 and 0 is actually stored at hardware level, how it is being handled in the respective cases of different types of memory, whether it is SRAM, DRAM, SSD, etc. So yeah, I hope you have enjoyed the video, and if any feedback, any questions, anything is there, please feel free to write in the comment section below. We'll try to answer all of that. Till then, we will be meeting in the next video. So till then, keep learning, keep hardworking. Thank you very much to you all.